which will become a part of the policy formulation. The circular economy, that's a term that is repeatedly used now. It's very relevant. So what is it that the mechanical and the chemical recycling that we are talking about here, how's that related to the circular economy? I'm sure my panelists are going to talk about that. And in the previous session and also yesterday, some very interesting practical solutions have been discussed here. And also, what are the operational difficulties? So, without much ado, I would just hand over to my co-chair. Thank you so much.
Professor, Institute of Chemical Technology. He has a PhD from the University of Leeds, UK, for studies on high-performance polymers, after which he did his postdoctoral research at the University of Illinois at Urbana-Champaign, USA. He has been awarded several other professional qualifications in the field of polymers, fibers, and coloration. Dr. Habbu was with the National Chemical Laboratory and then with Reliance. At his superannuation, he was leading the research and technology of Reliance's polyester sector. Presently, he is involved with various industrial bodies and associations, and he is also into mentoring activities on sustainability and circular economy of plastics. He has been on expert groups in various governmental bodies such as Indian Pharmacopoeia Commission, Bureau of Indian Standards, Food Safety and Standard Authority of India, and Maharashtra State Government Expert Group on Plastics. I would now hand over the session to Dr. Habbu's capable hands, and I know he has spent some time in curating the session. So,
immense capability of bringing back the schedule. Initially, we started we had a delay, and I was a little having goosebumps how to recover. But I think it's just 5 minutes delay. Ladies and gentlemen, what I intend to do is we have an expert panel here, and I'm not using the cliched word, but I know most of them, literally personally, and they bring together a pool of a variety of knowledge and insights into various aspects. So, looking at the desire that came from the audience of Q&A, the way I have formatted this session is, first, there will be first section in which I would request all the panelists to speak their minds. Either some of them will be speaking on platform, some will be through PPTs, and there are a couple of people who would be giving their videos from outside of India. So that will be the first part of it. Each of them has been given a time, so that they stick to the time is my responsibility. Part 2 I will open it up for Q&A, so that we have a lot of room for Q&A. So with this introduction of the format, let me start. I have to lay the platform. I have my own slides, so that we are all brought together on the same page. May I request the slides, please? Whatever I speak is in my personal capacity. I am not speaking on behalf of any organization, because I am involved with various organizations, and many times some of the statements that I may make may be in conflict with the organizational positions. So this is my own personal thoughts. So this is, for this audience, all these benefits of plastics needn't be told. But what needs to be highlighted is the fact that some of these advantages turn against plastics. 3 of them being lightweight, therefore they are visible. They are durable, so they do not get disintegrated as you would like them, like the plant leaves disintegrate. A statement was made in passing that plastics, Jayesh bhai, so you would, Rambiaji. So like a statement was made that plastics are there for thousands of years. So these kinds of very careless statements should not be made. Plastics got invented just 50, 60 years ago. So how can anybody make a statement of plastics are in the environment for thousands of years? So this kind of sensationalization should be avoided. That's just the point of this slide. So the visibility of its litter kind of outscreams the actual environmental superiority of the eco footprints. When we say plastics, a lot of narrative is said that good or bad, ban plastics and everything, little realizing that plastics that is really a matter of concern are the packaging plastics, which is but one sector, one function of these plastics. If plastics were banned in the kind of universal sense, there are other sectors that would get affected. So our grammar of governance should be very careful. What we speak, the slogans that we raise, the statements that we make should be really very careful with full intention. The single polymer packaging, such as what the examples that you see here, followed by MLPs, but all polymer MLPs, multi-layer plastics. But all the layers are made of plastics. And the third are multi-material plastics. So that is in the current latest division, it is called category 3. The reason I put forth is that, as the complexity of the packaging format goes, it is for a purpose that it gives you better shelf life. But nothing is perfect in life. So as you get one benefit, you have another disadvantage, that the more complex you make the packaging, then that much difficult it becomes for recycling. But the difference we need to understand, it's the brand owners that decide the packaging format that will be used, and they try to balance the shelf life and the functional properties that they desire in their products. Plastics into either repurpose. So within chemical recycling, you have what is called chemolysis, in which you have purification, you purify the polymers and then reprecipitate them, or you decompose them. And the way you decompose them is called solvolysis. Lysis means like dialysis. Means lysis is breakdown, solvo is solvent. So using solvent, if you break down, it is solvolysis. So that solvolysis, within that, there are several options. We are not going into the details of this thing. There are glycolysis, you can have hydrolysis, methanolysis, aminolysis, ammonolysis. These are just kind of a glimpse of the various technologies that can be employed in the chemical recycling process. Subsequently, you have thermolysis. That means instead of chemolysis, you can go for thermolysis, in which the most talked about is pyrolysis, in which you take the plastics and subject them to certain conditions, which we will discuss later by the experts. But here is just a snapshot of this. So pyrolysis, after that, a subsequent process is what is called gasification, in which you take the polymers from the original state of what we got from crude oil exploration. So as a summary of recycling, there are various techniques in mechanical recycling. You have bottle to fiber or bottle to bottle. And then in chemical, I just mentioned everything, but you need not kind of label yourself on these things, trying to remember what this is. This is more for an academician's delight than for anything else. And what is also not talked about, which is an emerging technology, is biological recycling, which is an enzymatic hydrolysis. It's wrongly pronounced as Vasudeva, Vasudeva Kutumbakam. It is Vasudhaiva, Vasudha Eva Kutumbakam. Vasudha is earth. Vasu ko dharan karne wali Vasudha. That is earth. Vasudhaiva Kutumbakam. If you have to look care of the Mother Earth, then all these options we need to kind of be aware of, and therefore process temperatures, what are the chemicals deployed, are also an important part of decision-making process. And contrary to the claims made, what are the actual operational capacities available or installed in the world? That is also a reality check here. Essentially, this chart shows, and it's not by me, it's by economist impact, and it's a fairly recent chart. So recycling facilitators that have been said is you can have this technology or that, is decomplexing the kind of packaging. In the previous slides, I showed you the various complex formats of packaging, which were thought that they are necessary for preserving or providing the shelf life. But now, can we not use polymer science? And in this entire space, it is my personal observation that the teams who talk about these things are primarily advocacy groups who are Vasudha. Thank you very much. So this was just to set the stage. Thank you. So this was just to set the stage of the recycling options and where the problems are. And with this, I would request my esteemed panelists one by one. I would invite them.
Hello everybody, my name is Edward Cozier. I'm the Managing Director of NextTech and NextLoop. My specialty is the recycling of plastics materials, and thank you very much to the organisers of this mega conference on focusing on recycling of and recovery of plastics. I'm going to share my screen now to give my presentation. So, the title of my talk is Pursuing True Circularity for Plastics, and this is a case study on polyolefins. And a brief word about what we do. NextTech is a company that is a design and research consultancy. We first of all developed recycling technologies to make the recycling of post-consumer plastics better, and potentially replacement of virgin plastics. And we also develop designs for recycling factories. And we have made many designs over the years, both in Europe, USA, South Americas, Asia, Australasia, and so on. And we are advisors to many organisations to help them improve the recovery and recycling of plastics. But before I talk further about my topic, I think it's important to quickly reflect on the United Nations Environment Assembly and the Global Treaty on Plastics Pollution that has yesterday been agreed to. This is really quite an important announcement. This is something that has only just recently been discussed in detail, but now we have a resolution to address the issue of plastic waste and to develop a legally binding agreement by 2024. And this resolution will address the full life cycle of plastics, including the production, design and disposal of packaging materials. Use for a short time is a critical feature because we have ended up damaging the environment by unmanaged materials leaking into the environment. And of course, a global problem needs a global solution. And many companies have voiced their concern over this issue and indeed are prepared to support a pact and a treaty that would become legally binding. So we're in 2022 and the search is for a legally binding agreement by 2024. And this has significant implications for countries that need to change the way they handle plastics, especially at the end of life. And of course, this means that there should be support for countries that are going to dramatically change the way they handle these materials. Polymer stream, high-density polyethylene, PET, polypropylene, etc. And these materials have to be cleaned, they have to be size reduced, and we have to wash them to remove any residues. And ideally, we would also remove any coloured flakes and remove contamination from those materials. And this can happen both physically, by separation of materials, and also by degassing techniques such as high temperature and vacuum being applied during extrusion and post-extrusion. And of course, the whole focus here is to replace virgin plastics. And here is one example of one company that uses high-density polyethylene with a modified process to make this material highly decontaminated. And of course, this happens to be only one process. This is a vacuum advanced, and the conditions here show that the materials are, after washing and drying, subject to preheating and degassing prior to extrusion. Now, the reason for making this point is materials can be exposed to a time and temperature where the polymer could be subject to thermal stress. Thermal stress during decontamination, thermal stress during extrusion. This, of course, has an impact on the properties, especially of polyolefins. Now, I have a table here about what happens when we go to a circular economy. Now, if we're adding, let's say, for example, 50% of a recycled material back into a virgin compound, the next time that product comes around for recycling, we end up with 25% of the polymer being recycled 2 times. And when it comes around again, 12.5% will have been recycled 3 times, and so on. And so you can see with this table, as we increase the recycling rate, as we approach equilibrium, we end up with a whole range of heat histories inside that polymer. And we have to ask, what is happening to the mechanical properties? Now, we do know that mechanical properties will change, and also the colour can also change during this process. And my point here is that while many companies want to go to 100% recycled content, it means that we will have a greater acceleration of the changes in mechanical and aesthetic properties. And it showed that when high-density polyethylene and low-density polyethylene are recycled, and this is going up to 100 times, we initially always see cross-linking occurring and we get an increase in viscosity. In the case of high-density polyethylene, after a large number of cross-linking reactions, we could see chain scission start to dominate as the molecular weights get higher, which is understandable. In the case of low-density polyethylene, we don't see chain scission interacting, and we end up with steady increase in viscosity, which would correlate with an increase in molecular weight. And of course, this also leads to changes in the processing behaviour and the surface appearance of these materials. Now, the antioxidants that are used are well known to the formulation industry, and typically all polymers, all polyolefin polymers, have antioxidants of one or two types. Either they're phenolic antioxidants or they're based on amines, could be hydroxylamines or others, and there are also phosphites that are added as well. So these materials are typically added at low concentrations in hundreds of parts per million to protect the polymers. The use of these materials has been used to, for example, change the behaviour of these materials during.
Comes in it that the flakes that you bring in would have seen multiple recycled lives. We'll come to these details a little later. But what happens in polyaddition type of polymers was kind of being explained by Mr. Cozier. Similar things can happen for other polymers having other chemistries. So these are kind of scientific aspects, but at the ground level, we have to learn from different countries. As the Indian adage says, "Ano bhatak pratamu yantu vishwata." Let us have learning from all countries or from everywhere. So we have with us today Yuki Yoshida-san, he's an attaché at the Japanese embassy, who will tell us what exactly happens much before the recycling chain sets in. How is it that in Japan they handle these topics? So Yoshida-san,
good morning everyone. My name is Yuki Yoshida from the Embassy of Japan in India, and I'm covering the entire environmental field in my embassy. So if you have a question or some comment on my presentation, please don't hesitate to call or contact me. So let me begin. So in India, packet of plastic which made for the package, and 84% of plastic waste will be utilized as thermal recovery or chemical recovery in Japan. So which means the collection of Japanese local government has successfully by recovering such waste to convert it to energy or some kind of materials. So why that happens? So I think this is achieved by almost perfect collection and segregation by the local government. I think segregation is a key role to play for recycling and processing plastic waste. So recently, Japan initiated pricing to plastic bag, but easy to scatter plastic has not banned like India, because it is not needed to implement such scheme thanks to high segregation and process rates. That is Japanese recent circumstance. So in the next slide. So from next slide, address the Japanese contribution to India in a balanced way on the waste management. So, with the experience of Japanese country, so Japan would like to share our knowledge and experience to other countries which is currently emerging the problem caused by poor waste management. So we have provided various supports such as waste management and capacity building to local government and enhancement of awareness of citizens. So let me elaborate this. So you can see this slide from the left side of the picture. So this is made by the Yacho Engineering, is a Japanese company, has dedicated India for exceeding 10 years. They installed sanitary landfills in West Bengal, nearby Kolkata, and taught people how to segregate garbage between biodegradable or non-biodegradable waste. So these wastes take forward to recycling and composting, incinerating, and dumping. And also, they taught the maximum use of resources are helpful for people life to saving money and the environment, as well as to keep hygiene and their residents. At the second picture, the right side of the picture is an incineration plant made by Hitachi Zosen. Hitachi Zosen is one of the Japanese companies to construct waste incineration plant. Hitachi Zosen has installed their waste-to-energy plant, which is useful to reduce the amount of waste and generate the electricity. And that is currently drawing attention to all over India. So in India, especially at our area, it is getting a serious problem about the treatment of waste. This is vast amount of quantity and the people cannot find a place to dump that waste. So that this kind of technology will be a key to resolve problem on the waste management side and also contributed to young child as a school kids or teacher in primary school. So the storyteller is some Japanese picture book which shows Japanese traditional mind called mottainai. Do you know mottainai? So the mottainai philosophy expresses Japanese habitat, which is using resource at a several time. That mind is like don't litter at once use, don't waste no necessary water, and don't eat too much if you cannot eat everything. So that is the philosophy of the mottainai system. The superheated steam generator provides it into the reactor and makes inside the reactor high temperature and oxygen rich. Waste in the reactor starts to be decomposed by heat. A part of the organic matter like food gets converted to carbon, and plastic waste gets recycled to oil. And the material is not converted to something, so material is to be materials. So waste thrown in the reactor reduce their volumes drastically and get converted into materials except metal. So I explained earlier, so plastic to the oil and food garbage put into this facility and goes to this facility to convert to oil or materials or something like that. So this is the salient feature of this product. And this one. This one is from the Malawi. This is a Japanese training and investment company. So this technology is not origin of Japan, but it has been distributed by a Malaysian company in India. So this is called P-Life. P-Life is additive that allows manufacturers to custom tailor the life of every plastic product they make without compromising the shape of performance or function. When added to polyethylene like LDP or HDP and polypropylene PP, P-Life creates a molecular section in the polymer chain, allowing oxygen to bond to the polymer and break it down into smaller and smaller compounds, which can be naturally consumed by microorganisms. So this result is a plastic product that will begin to degrade in a few. So UNEM 5.2 adapt the plastic, adapt the resolution of the plastic pollution. And furthermore, this year marks 70th anniversary of establishment of diplomatic relations between India and Japan. This event will lead further collaboration of each countries and India and Japan's to strengthen the bond of each countries. Thank you very much.
Before that happens, we now have a person who has breathed or lived his life in recycling, doing mechanical recycling. And keeping in mind the format that we have a lot to extract from people during the Q&A session, I would request Mr. Aditya Dalmia, we will invite him and request him to give his free-flowing thoughts, and we will keep some of the best part of his, we'll extract the best part of his wisdom during the Q&A session. So,
good afternoon, everyone. I'm Aditya Dalmia from Dalmia Polypro Industries Private Limited. We are basically a recycling company. We do mechanical recycling. Apart from recycling, we also do the collection of plastic waste, which is an integral part of our recycling activity. So we are in this business. Recycling in India is a very, very old, thing that is happening, but unfortunately, it has been happening only in the unorganized sector. I would say that the unorganized sector is doing a very good job for us in India. Like basically, the whole concept there is that they buy cheap, collect cheap, make cheap products and sell cheap products. So that is what is going on. So whatever little value that is there in the plastics, only those kind of plastics are collected, which can definitely be recycled. So the essence of really collecting everything is not been there because they have a very limited value that is available for them to recover after doing all the processes. And we have huge clusters all over India, like the Dharavi or the Mandala or Doraji. All over India you have these clusters. And even for collection of plastics, I mean, if my data is not incorrect, we have over 4 million rack pickers working across the length and breadth of India, who are actually collecting. Apart from them, assisting them is more on the, what do you call, the housekeeping staff, etc. Even all these wares, they're all sold to local kabari walas, basically, and which you can find in any lane of India, where they are actually collecting all the scrap, whether it is plastic, paper or anything. So we have entered into this fleet as mainly as a PET recycler, which fortunately has a versatile use and has slowly over the last 1.5 decades got more organized. Due to which, what we find is that the collection of PET is really grown. So basically, the most important aspect in whether it is mechanical recycling or whether it is chemical recycling, the collection of waste is important. Both require the right polymer, both require, and you cannot just mix anything because all polymers are different. So collection, sorting, and then recycling, and upcycling, like someone was mentioning that it is downcycling when you don't make good products out of it. So the good products can only be made when there is a demand for good products. Unfortunately, there has never been a demand, especially in the polyolefin sector. None of the big companies ever wanted to replace virgin plastics with recycled plastics because they never got the right product. So, and it was never ever produced because there was no demand for it. And the capex and all this is so high that normally people would not want to invest. But fortunately, I think the whole scenario is now changing. From what you call a recycler was first maybe called a kabaliwala, that is how he was termed. It was looked down as an industry, it was never looked up as an industry. But today this scene has changed it and it's now from a kabaliwala industry, it's becoming a sustainable industry or a green industry. So this is how the whole concept has changed. And we find a lot of multinationals, a lot of people creating a lot of interest in actually wanting to now use recycled material. And even the governments have been supportive. They are coming out with legislations mandating the use of recycled, and it's very encouraging to know that even this has now been permitted for use in food grade. So what we are seeing now is that we'll be finding a lot of good technologies coming in. And we ourselves are setting up a new venture wherein we'll be making food grade PET resins which will be used back into bottles. We'll be again making food grade polypropylene polyethylene which will go in for various other filling applications with the large multinationals. So there is a great scope in recycling, especially in mechanical recycling, because that is already there, that is a proven technology. Chemical recycling is picking up, definitely, but that's more expensive, and even the operational cost, what we understand, is little more expensive than the mechanical recycling, which is fairly easier to do. So there are a couple of things. As a recycler, what are the challenges we face? Normally, as a recycler, the challenges are the collection of the right material. So the right material that can be always be collected, because we've got a fantastic collection system in India, which I don't think is available anywhere in the world. We find that whatever we want is very easily available for us. So what we need to do is, rather than trying to push in terms of trying to collect plastics, what we need to do is actually pull plastics. There's no value attributed to that. That's the reason why it just finds itself in the landfill or into the oceans. You will never find a PET bottle, normally you will not find it on the road because it's picked up immediately, because value has been created for that. So similarly, even another thing what we would say is that design is very important. That at the stage of manufacturing any packaging material, if you design the product correctly, it will help you recycling, and it will also avoid landfills. I'll give you an example of a PET bottle. A PET bottle, the structure is definitely PET, but it has three kinds of labels. You have a PET label, PETG label, you will have a PP label, you will have a PVC label. Now for a recycler, that's a great challenge because all three of them are very difficult to recycle. So if we have one standard label, one is that we recover that plastic. Because today, presently, that all goes to the landfill. Because all the three labels get mixed with the recycling and there is no way you can segregate that. So if one standard label at the time of designing or maybe legislation would make life easier, and you will actually recover that bottle. Similarly, in your caps you have a polypropylene and polyethylene. You should have just one sort of a polymer used in the cap. So because that will create more value for the product. So so what I see now is definitely with so much of